Hi there, it's Jason Gorman with the second video in our series on test-driven development in Java. If you haven't seen the first video on the TDD cycle, the 3 steps of TDD, then I highly recommend you take a look at that video first. There'll be a link in the description below. This second video, we're going to be expanding what we learned in the first video to talk about some good habits to try and get into as you do test-driven development. So if we just remind ourselves about the 3 steps of the TDD cycle, we start by writing a failing test that describes what we want our software to do that it currently doesn't. So a test is a specification, if you like. And then we write the simplest code that we can think of to pass that test. And then, if necessary, we refactor our code to make it easy to change going forward so that we don't end up in a situation as our code grows where change is getting harder and harder and harder. So, a red light, write a failing test. Green light, write the simplest code to pass that test. And then, if necessary, refactor the code to make it easy to change going forward. Now, that's all good stuff. And if you're doing that, then you're doing test-driven development. So, with one test at a time, you're fleshing out your solution design, as we will have seen in the first video. But there's more to it than that. And what we're going to discuss in this video is 3 things, 3 habits, if you like, that I found over the last 20 years of doing TDD tend to make it more effective and more sustainable. Now, the first of these is, if you remember from the the first video, I started when I was writing my unit test by writing the setup first and then working my way through to the assertion. And that would seem logical. Start with the setup, call the method or the function that you want to test, and then assert what should be true at the end of that. But I found it works better when you actually do it the other way around. So rather than, let's say, in the example we're doing here, we're going to do tests for donating movies to a DVD library. And we have a test that's going to ask, okay, is this donated movie in the library? Now, we could start by saying, okay, well, we're going to need a library and etc. As part of our setup. But we're not actually going to do that. We're going to start at the end. Start by asking the question that we want to ask. So ask the question that we want to ask, which is this library in the movie, in our library's catalogue? So let's imagine that the catalogue is a list there. So we write our assertion first and we work backwards to the setup. So it's telling us now, okay, well, we're going to need a library then. So let's declare that. And that's a class that doesn't exist yet. So let's declare that class. So I'm working backwards from the setup, declaring code as I need it to get me to a point where we can ask that question. So let's instantiate that. And now it's telling us, well, our library class is going to need that getCatalog method. And we're going to make that a collection of movie. Okay, and again, it's saying, well, there's no such thing as a movie, so let's create that class. And let's just return now null, just so that it compiles. Okay, and then we're going to need our movie. There's our movie. The class exists now, so we can just do that. And then we're going to donate our movie to the library. So we get to the action that we want to test. And it's telling us here, okay, well, we need to declare that method, so let's do that. Okay, so we're working backwards, and you'll see how IntelliJ is actually helping me to do that. it's kind of designed, the editor's kind of designed with working backwards in mind. So the flow of this is, to a lot of people at first, seems counterintuitive. We write our assertion first, which means that we are referencing things that don't exist yet. And then we're working our way backwards from the references to the declaration. So we reference a local variable called library, so we then need to work backwards and declare that library. And we say it's of type library, of class library. Therefore, working our way backwards again, we need to declare that class, and so on and so forth. So the reference always comes first. And this is very much the essence of test-driven development. We refer to things in a test. We use something in a test, and that forces us to declare it. So it's test-driven in a very, very strict kind of way. And that means that I end up with the setup, exactly the setup I need to ask the question that I want to ask. The number of times where I've written the setup and then got to write the assertion and thought, oh, I haven't actually got what I need to ask that question. So we need to work our way backwards from the assertion, which makes the whole thing all about the question we want to ask, which is the most important thing about the test. Is this true? So there's our test. And that's kind of the flow. When I do TDD, most of the time that's that kind of backwards flow, working backwards from an assertion. And I find it from a design perspective, it's quite powerful psychologically, because you're starting with the what. Here's the question. And you're working your way backwards to the how. Now, that's point number one. That's habit number one. Work backwards from the assertion. Write the assertion first and work your way back to the setup. The next habit that I want to talk about is, before I write the code to pass this test, and you will have seen me do this in the first video, but I didn't explain why, but I'm just going to run this test and see what happens. My IDE is having a little think. Good old Java. And hopefully in a minute we'll get a failing test. Okay, now, we have a failing test, but look at why it's failing. It's failing because we're getting this null pointer exception, because we're trying to check whether an object is in a collection that's actually null. We're returning null at the moment. Now, what I really want to know at this point is, if the result of this test was wrong, would this test fail? So I don't want to see it fail because of some unhandled exception. I want to see what happens if the donated movie is not in the catalogue. So for now, what I'm just going to do is just return an empty array list like that, so that we don't get that unhandled exception. We actually get to see whether or not the test assertion catches the problem. It catches the fact that we haven't added our movie to the library yet, to the catalogue. Okay, so now we're getting an assertion error. So our assertion is actually failing. So this is habit number 2. Before you write the code to pass the test, see the test assertion fail. The reason for that is so that going forward, we can have confidence in this test that if we broke this code as we change it in the future, this test would actually catch it if this part of the code was broken. So we're testing our test before we make it pass. This is a good habit to get into, because I've seen many, many test suites over the years where all the tests are passing, but the code's actually hopelessly broken because the tests aren't really asking meaningful questions. Quite often it happens because some boss somewhere has insisted that the team get 100% test coverage, so they're just going, okay, well, in that case, assert true. And they get their test coverage, but they're not actually asking any meaningful questions. So run your test and see that it really does fail when the result is wrong, when the answer is wrong. And then you could have more confidence in your unit tests as regression tests going forward. And that's very, very important. Excuse me. Okay, so that's habit number 2. See the test fail. Habit number 1, assert first and work backwards. Habit number 2, see the test fail, so that you know that it's a good test going forward. Okay, now let's do the simplest thing we can think of to pass this test. So this can't really be... let's see if we can introduce a field. Let's call it catalog is what I thought would be a good name for it. So let's call it catalog. And I really didn't want that to happen there. So it's no big deal that it does. But don't know what happened there. So, just a new array list is fine. Okay, so we're going to return the catalog here, and when we donate, all we're going to do is add our movie to the catalog. And that should all work spiffy. Okay, let's run the test now and see it go green. Let's see the test pass. Lovely. So we've done what we needed to do, and we've got our test passing here. It's time to think about refactoring. On the whole, there's not too much here to worry about, but there is one thing that's bugging me here, which is we've got what's called a message chain. That's when we're navigating through a relationship to one object to the next object in the chain. And in this case, what's happened here is we've unencapsulated this list. So our client code knows that it's a list, it's a collection. That's a little messy. I like encapsulation. I'm a big fan of encapsulation. So let's just quickly encapsulate this. So let's create a method called contains that takes a movie and a library. Okay, and immediately rerun your tests as soon as you perform that refactoring. And now let's move this to our library. Okay, it's going to make it. There you go. It's going to make it internal so that we can see it. And there we go. Bit of refactoring there. Okay, now there is a second requirement that when movies are added to the library, we also register, we add a single rental copy. So we track how many copies are available to rent. And when we add our movie to the catalogue, we also need to give it one default rental copy. So let's write an assertion for that. So what we're saying is a movie, let's call it get copies, should be equal to 1. And just import that. Let's create that method. Int, good guess. Okay, now when we run this, let's just take our movie class. We will need to return something here, so let's return. So sometimes you will choose a data value. It would be very easy for me to just do that and pass the test. But sometimes we deliberately choose a return value or a data value so that we can see the test fail. So make sure that your data is such that, you know, if it's just a placeholder, for example, choose a placeholder value that will make the test fail. Okay, yeah, expected 1, but it's actually 0. Now, we could just do that, and we could triangulate this, but quite honestly, I don't think that's a good use of my time to triangulate this, to go through a number of different test cases for something as trivial as this. So this is an obvious implementation. We'll discuss obvious implementations in the next video. So I'm just going to implement the obvious implementation there. There's our field. Okay. And I guess what we need to be able to do in library is when we donate, we add a copy like that. So let's just create that method. Oops. Okay, our test is passing again. So it's time to think about refactoring. I'm happy with movie. I'm happy with library. Oh, there's one thing we can do with library now because we've encapsulated. I should have done this earlier. We don't need this anymore. It's always very comforting to see our getters and setters disappearing like that. That's a good sign that we've got proper encapsulation. Okay, and actually there's a bit of simplification. I didn't notice that, so we don't really need this anymore. And again, rerun our tests. So it is very, very important when you get to a green light, when your tests are all passing, that is the point at which, at your leisure, you can sit back. Because your code is now working, you can ship it if you have to. At our leisure, we can sit back and examine the code and think more deeply about the design. Okay, so there we go. Now, the test code, there's something about this test that's bothering me. If this test fails, there's two reasons it could fail, basically. There's two reasons for this test to fail. And what can happen is when we overload our tests, so they're asking lots of different questions, is it becomes harder and harder to see specifically what's gone wrong here. In JUnit, for example, if that first assertion fails, it won't actually continue to run the test, which means we won't know if the other assertions are passing. So it can get quite difficult then to pinpoint exactly what's gone wrong. So your tests need to be specific. They should have just one reason to fail. So that they more accurately pinpoint exactly what's gone wrong. So what I'm actually going to do is I'm going to refactor this. Let's turn this into a field. And we're going to instantiate that in a constructor, yeah. And rerun our test. You'll see why I'm doing this in a minute. Likewise with movie, we're going to turn this into a field and set that in the constructor. Okay, now I'm just going to cut that, and we're going to create a second test which is specifically about the rental copies. So we can donate. A little bit of duplication here, that's fine. We'll talk about that in the next video. So donate our movie, again, there's our action. And we're going to assert. Oh, no, I just need to paste that, don't I? Cut and paste. Copy and paste, bad. Cut and paste, fine. Okay, now let's run both of those tests. Excellent. So now each test is about one thing. I'm going to rename this test to movie added to catalog. So it's very, very important to maintain your tests, to keep them in step with the code and what they mean, what the code means. So if you've changed the meaning of a test, you need, for example, to rename the test so it accurately reflects now the meaning of that test. So each of our tests only has one reason to fail. If the movie's not been added to the catalogue, the first test will fail. If the rental copy's not been added to the movie, then the second test will fail. So there you go. There's 3 good habits that make TDD more effective and more sustainable. Habit number 1, write the assertion first and work backwards to the setup. It takes a little bit of getting used to, but you will get there with practice. Habit number 2, make sure that before you write the code to pass the test, you've run the test to see that it does fail, and specifically that the test assertion fails when the result is wrong, so that you can have confidence in that test going forward as a regression test, should you choose to keep the test as a regression test. And then finally, we tend to find that TDD works better when tests only have one reason to fail, so that when a test does fail, it takes you exactly to, this is the problem, this is the part that's gone wrong. So 3 habits for TDD. In the third video, we're going to be talking about what tests should we be writing, what tests tend to lead us to the best designs. So that will be coming very, very soon. Cheerio, bye.